Okay, welcome to part 3 of Unit 3.3, Introduction to Trigonometry. So now what if we're trying to figure out what an angle is? So we know a couple of sides of the triangle, but we don't know what the angles are inside the triangle. So this time we have to first, like before, we have to first learn how to use our calculators to do this. So, all right. We know, let's say you want to know what the tan of 24 degrees was. So you just type in tan of 24 degrees. So I go over here, I go tan of 24 degrees, and I get 0.4552, and so on. So that's rounds to about 0.4552. But what if I didn't actually know that the angle was 24 degrees, but I did know that the ratio turned out to be 0.4552 when I divided the tan is TOA. So when I took the length of the opposite and I divided it by the length of the adjacent, and I got 0.4552. Well, then the question is, what is the angle? So there is a way to do this on your calculator. You'll see above sine, cos, and tan on your calculator, you'll see sine to the -1, cos to the -1, and tan to the -1. We don't say sine to the -1, cos to the -1, tan to the -1. We call those sine inverse, cos inverse, and tan inverse, because they are what's called the inverse functions of sine, cos, and tan. They undo what sine, cos, and tan do. Just like square rooting undoes squaring, sine inversing undoes sining. Does that make sense? So the way that we would write this, if this was the question that we had, we would say, okay, the tan of theta equals 0.4552. To isolate the theta, we need to get rid of the tan, so we tan inverse 0.4552. To do the tan inverse, because it's above the tan key, you need to use that second function or the shift key, whichever one you have on your calculator. So on my calculator, I have to hit function, and that will give me tan inverse. Oops, I forgot to clear that. So let's try that again. Tan inverse, and then I type in 0.4552. And it tells me then that theta is the angle 24.5 degrees, rounded. Now you'll notice that originally we started out with 24 degrees and got 0.4552. But when I did the tan inverse of 0.4552, I got 24.5 degrees. That's because I'm only using 4 decimal places. That's how touchy trig is. The trig ratios are. You add a few more decimal places and you get more accurate answers. So this is why when we're doing a question, if our ratio is already set up as a fraction, we leave it as a fraction because we want it to be as accurate as it can be. You don't want to turn that fraction into a decimal equivalent or a decimal approximation of the fraction, or you're not going to get as accurate an answer. So this is going to be illustrated in the next example. So let me move to the next example here. All right, so let's consider this triangle here. We want to find theta using the sine ratio. So if theta, this is my reference angle again. I seem to keep putting the reference angle in the same spot, but I hope you realize that if I move the reference angle, that just moves where the opposite and the adjacent are. The hypotenuse is always going to be here. So this side is the opposite side, this side is the adjacent side. So if I'm using the sine ratio, again, SOHCAHTOA, sine of theta equals opposite over hypotenuse. So sine of theta, I still don't know what theta is, but I know that the opposite side is equal to 3, and I know that the hypotenuse is equal to 5. So then now to isolate the theta, I have to sine inverse the opposite side. Leave that as 3/5 when you go to calculate the angle. In this case, we know that 3/5 is equal to 0.6. It's not a run-on decimal, repeating or otherwise. So it's not going to make a big difference for this question, but it will make a big difference for other questions. So leave that as 3/5. So when you go to calculate it, again, with a 2-line display, I'm going to go to sine inverse, and then I'm just going to type in 3 divided by 5 and end bracket. No, I guess I didn't really need that, but okay. So that tells me then that theta equals 36.9 degrees approximately. If you have a 1-line display, you need to calculate what 3 divided by 5 is. So you're going to type in 3 divided by 5, then hit the equal sign. And then you're going to hit your second function key or your shift key, and then hit your sign key, and that should give you the same answer that I have. So try it and see. Make sure that you can get this answer of 36.9 degrees. And again, like always, contact me if you're having some trouble with that. Okay, so on the next page, I want you to try and figure out what theta is by using the cos and using the tan. I guess this doesn't apply to the video. You're not going to cover up the solution. What you're going to do is you're going to stop the video right now, and you're going to go through the motions of figuring out what theta is using cosine and using tan. So, SOHCAHTOA again. All right, so for cosine, cos of theta equals adjacent over hypotenuse. So cos of theta, this side is the adjacent, this is the opposite, this is the hypotenuse. So adjacent is 4, hypotenuse is 5. So theta equals cos inverse of 4 over 5, which should be the same as what we just did. So second function, cos inverse, and 4 divided by 5. And again, that's 36.9 degrees. Imagine that. It should be. It's the same angle. Now let's try it again with tan. So tan of theta equals opposite over adjacent. I still don't know theta, but I know that the opposite is 3 and the adjacent is 4. So theta would equal tan inverse of 3 over 4. And again, let's go back. We're going to do second function, tan inverse, and then 3 divided by 4, and that equals, again, 36.9 degrees approximately. Okay. All right, now it says find the indicated angle for each of the following. I guess, again, you're not going to cover up the solution. You're going to stop the video and try it on your own first, and then start the video up again and see how you did. So stop the video now. Okay, welcome back. So this is my reference angle. So this side is the opposite, this side is the hypotenuse. So in this case, you're not asking yourself, what side do I know and what side am I looking for? We know both sides. So this time you're going to ask yourself, which two sides do I know? And again, let's go SOHCAHTOA. Opposite and hypotenuse is sine. So sine of theta equals opposite over hypotenuse. Sine of theta equals 18 over 25. So theta equals sine inverse of 18 over 25. And second function, sine inverse 18 divided by 25. And that gives us 46.1 degrees. For the second one, this is my reference angle. That side is the opposite. This side is the adjacent. Here's the hypotenuse. I don't know anything about the hypotenuse, so we're using opposite and adjacent. That is tan. So tan of theta equals opposite over adjacent. Tan of theta, the length of the opposite is 18, the adjacent is 25. I'm trying to find theta, so I've got to get rid of the tan, and to get rid of the tan, I tan inverse the opposite side. So second function, tan inverse of 18 divided by 25 equals 35.8 degrees approximately. Okay, I think that's it. So prior to the break, I asked you to do page 398 to 399, numbers 1 to 15. If you haven't done that yet, do it now. If you've already done it, then you still have a little bit longer. I'll post another lesson tomorrow. Okay, have a good night, good day, whatever time of day it is that you are looking at this.